Section 6-1, Part 1. This is an example of identifying systems of linear equations. Determine whether each of the following represents a system of linear equations. So let's look at A part. Is this a system of linear equations? Y equals 1.5x. Yes, that's a linear equation. It is in the form of y equals mx plus b. Also, I know it's a line because both the x and the y are to the first power. So this is a linear equation. The question, is this a linear equation? Yes, it is a linear equation. It's in the form of y equals mx plus b. And both the x and the y are raised to the first power, and I do have equal signs. So A is a system of linear equations. So y equals to 1.5x and y equals to 2x minus 1. That is a system of linear equations. Notice I've divided my paper into the left side is a system of linear equations and the right side is not a system of linear equations. So A would be yes. Okay? Let's look at B part. X equals 2. Yes, that's the linear equation. Y equals to negative 3. As long as you have an equal sign, as long as you have either an X or a Y, that is a line. When the X or the Y, when the X is raised to the first power and Y is raised to the first power. So B part is also a linear equation. X equals to 2 and Y equals to negative 3. They are both lines. So yes, this would be a system of linear equations. We could find out where the two lines intersect. Looking at C. Is this an equation? No. To have a system of equations, you must have two linear equations. I don't even have one equation. I don't see an equal sign. So C is not a system of equations because it is not a linear equation. So C is no. Looking at D. D, is this an equation? Yes. Is it a linear equation? Yes, it's an equation because it had an equal sign in terms on the left and terms on the right. It is a linear equation because both the x and the y are raised to the first power. Now, if they're on the same side, if the x and the y are on the same side, they either have to be added or subtracted, and mine are. So yes, this is a linear equation, but to have a system, you have to have two linear equations, and we do not have two linear equations. Therefore, D is not a system because I do not have two linear equations. So D, again, would be no. Looking at E. E, is this an equation? No. So if it doesn't have an equal sign, it's not an equation. I have to have two linear equations to have a system. So E would also be no. It is not an equation. F, looking at F. Do I have two equations? Do I have two equal signs with terms on the left and terms on the right? Both of these are in the form of y equals mx plus b. Both x's, both y's are raised to the first power. Therefore, yes, both of these are linear equations. Both of these are lines. So this is a system of equations. So F would be yes. F is y equals to x and y equals to x plus 5. This is a system of equations. My answer is yes. And looking at G, the last one. G is 2.5x minus 3.75y equals to 5.5. This is a linear equation. The x and y are on the same side. They're raised to the first power. They're added or subtracted. So as long as they're added or subtracted, it would be a linear equation. Both the x and y are raised to the first power. It does have an equal sign, terms on the left, terms on the right. So yes, this is a linear equation, but I need two of them to be a system. one linear equation is not a system. So ends up G would be no. 2.5x minus 3.75y equals to 5.5 is not a system of linear equations.